Okay, cool. Okay, so before we talk about naming acids and writing formulas, let's talk about acids in general. So like between acids and bases, what are, like, y'all have heard of that before, right? So what are some common uses for acids and bases that you might find around your house or just in life in general? Yes. Cleaning products. Okay, so what comes to mind? Like what type of cleaning products? Bleach. Okay. Yes, and I always thought that bleach was an acid. Bleach is actually a base, I believe it's a strong base. What other stuff? What are some other acids or bases? There's tons, right? There's things that are acidic, right? They may not be an acid, but they're acidic. What's that? Lemons, okay, yes. And that's why they can kind of be used in cleaning stuff, right? Yes. Milk is slightly basic. Yes. So let's put like this list over here is things that are basic or acidic, right? What are some other drinks that are acidic? Coffee. Coffee is acidic. Soda is acidic, right? Have you guys ever heard of alkaline water to be healthy, right? So if you drink like Fiji water, right? Basically, there's an idea out there that more basic water is healthier for you. So Fiji water is more basic, right? Whereas the water from your tap water probably is a little bit acidic, like probably a pH of like 6.5. So acids and bases, you guys probably learned in the 8th grade about like the pH scale, or maybe in biology, right? It's tied into that. We're not going to get into that today. Other cleaning products that you probably would use are vinegar, right? Vinegar is an acid. What else? Drain cleaner, right? Oven cleaner. All of these are acids or strong bases. Oven cleaner. Lye. Have you guys ever heard of lye or even used lye? That's like was used in the old days for like basic cleaning, basically like soap. Soap is a little bit basic as well. So these are all used as cleaning agents, right? Because acids are really good about kind of eating things away. They're corrosives, right? And so if you've got something really stuck and you can't get it off with a weaker base like a soap, if you pour some oven cleaner on it or like sodium hydroxide, it's going to eat away at the rest there and clean it up. So acids are commonly used to clean things. Yes, but also some things are acidic, like these things that we drink all the time. We're going to learn about how to name them today. So you guys should have your notes out, and then also you should have your polyatomic ion sheet out. So it has like a list of the common ions so that you can refer to that while we go through. It'll be a lot of that. Okay. So first of all, acids, what would you guys guess acids begin with? Like what element is most always involved or most often involved with acids? Iodine, it can be in acids, but it's not in all acids. There's one element that's in almost all acids. Yes, hydrogen. So H, I would say that hydrogen, let's say it this way. Acids commonly start with an H. Commonly begin with H. Okay. And even though H is a nonmetal, it actually has a +1 charge, and that's important for later. Okay, so H is going to have a +1 charge basically every time. Okay, so acids normally begin with H. So there are a couple different types of acids. The first type is called a binary acid, and we know that bi means 2, right? So this has to do with only up to 2 elements, no more than 2. So when we name binary acids, there's certain ways that we name it, okay? So you put hydro in front, and then you fill in the name of the element, and then you put ic afterward and say acid when we're dealing with binary acids. So for example, if we had HF, first of all, we know it's an acid because it's got that H in front. So we're like, okay. And then we know it's binary because there's only 2 elements involved. So we're going to name it hydro, and then F is fluorine, right? So it's going to be hydrofluoric acid, right? If we had HCl, it would be hydrochloric acid. Oops, I always am spelling this wrong every day, every period today. I've spelled chloric wrong. I don't know why. Hydrochloric acid, like that, right? HI, I is iodine, right? So that would be hydroiodic acid, right? So you add an ic at the end and a hydro in front, and that's all that you do. And you just put kind of the first part of the element's name in the middle. It's a big sandwich. So when we're writing these formulas, there are certain times that there are more H's needed, like H2S, right? So the way that you know how to write the formula is the crossover rule. So even though this is covalent, we're going to use the crossover rule for it because H has a positive charge here. So in this case, H has a +1 and F has a -1. And so you just need one of each. And that's true for each of these three cases. But when you have H and then S, which has a -2 charge, you're going to need two H's, right? H2S, because you want to make the overall charge 0, right? So you need two H's so that you have a +2 charge. So in other words, you cross over the charges. So the 2 goes here and the 1 goes here, H2S1, right? But we don't need to write a 1 because it's just assumed that it's a 1, H2S. So this still is binary. There's still only two elements involved. There's just two hydrogens within it, but it's still binary. So it's going to be hydrosulfuric acid, right? And then if we wanted to do H and then N together, which has a -3 charge, that would be H3N because it crosses over. This would be hydronitric acid. Okay. So are there any questions on how we're naming binary? Okay, so we're about to get to the fun stuff, which is ternary. Okay. So ternary means three or more elements, which means that we are using the polyatomic ions on the back of our periodic table. Polyatomic ions. Okay, so let's pull our polyatomic ion sheet and look at some of these. So on your ion sheet, okay, look at your ion sheet. What do you notice the ions end in a lot of the time? There's two endings that are common for them. Yes. So 8, don't y'all love that music next door? I'm still trying to figure out what movie they're watching. It's like violins or something going on. Okay. So 8 and 9 are the common ones. So let's look at an example here. Let's say that you've got H2SO4. Okay, and we want to figure out how to name this. Well, first of all, we know it's ternary because there are 3 elements involved. And so we need to find out the name of SO4. So we're going to pull out our ion sheet and we're going to find SO4, and it's in that second column. And so we know the name is sulfate. Okay, so with ternary compounds, you don't use the prefix hydro. Okay, so you did the hydrosulfuric acid, right? We're not going to do hydro for ternary. And if that polyatomic ion ends in 8, we change the ending to ic. And if it's ite, we change it to us. Okay, 8 to ic, ite to us. So sulfate becomes sulfuric acid. If you had thought it was sulfic acid, I would have counted that as well, as long as you got the sulf and the ic, right? We call it sulfuric acid. So the 8 changed to ic, and that's the name. We don't do hydrosulfuric acid. If we said hydrosulfuric acid, it would be this guy with only 2 elements, right? So you don't put hydro in front. So another example would be H2SO3. So we're going to look, we say, okay, this is polyatomic. So SO3, its name is sulfite. And my rule tells me ite changes to us. And so it's going to become sulfurous acid. So does that make sense so far? So if you're given this name, you would have to write the formula. So I think acids are probably the hardest, the ternary acids. And then writing formulas, I think, is harder than the other way around. Like right now we're writing the name, but if I didn't give you this and I said, write the formula for sulfurous acid. You would have to go, okay, us, that means that it ended in ite. So that means that we're dealing with SO3 sulfite. And then, okay, SO3 has a -2 charge, and H has a +1 charge. So we're going to cross over and make it H2SO3 1, or just H2SO3, because 1 is just invisible, right? So that's kind of a lot of mental work, and you have to know this. So this needs to be definitely written down. Ate to ick, I to us. Oh my gosh, I can't do boxes. Okay. Anyways, I'm going to erase this real quick. Okay. So I'm going to do a couple more examples just because these are all just like of each type here. So I'm going to have you guys try on your own. Which one have I not done yet? Okay. We'll have you try HNO3. Okay. So I'll give you all a minute to look that up and try to find it. Okay. So you should have figured out, first of all, okay, this is ternary. So we're going to name it that way. It's ternary. And then we find out, okay, what is this guy's name? So what is the name of NO3? Nitrate. Okay, and we know from the notes we took, hopefully, that you change 8 to ick, right? So it's going to become nitric acid. And that's the answer. Okay, so I want you guys to try that now with HNO2. Is that on your sheet? Yeah. So what is NO2? Nitrite, right? Nitrite. And so ite changes to us, right? So it's going to be nitrous acid, right? Okay, so I think we're getting this right. So if it's ternary, you figure out if it ends in ate or ite, and you change it to ick or us. Okay. The only thing I need to add is I need to kind of make a note about I don't really even know how to explain what I need to make a note about, but I'm just going to start talking about it. So let me see here. Okay, what do you guys notice? So like, for example, I'm just going to pull 2 ions from the back. Let me find the right one. Okay. So between chlorate, which is just on the back, it's one of the polyatomics, between chlorate, which is ClO3, and chlorite. What's the difference between chlorate and chlorite on your chart? The oxygens, right? Okay, let's look at a different group. Let's look at, let's look at sulfate, which is SO4. Oh my gosh, I did a 3 for an S. Do you guys ever do that? Do you replace a 3 for an S? Because I don't know if there's something wrong with me, but I do that often. SO4, and then sulfite is SO3. So what's the difference between sulfate and sulfite? Yes, okay. But notice this. Chlorate has 3 oxygens. Sulfate has 4. And so because it ends in 8 doesn't mean, oh, it has 3 oxygens, right? It doesn't tell you for sure how many oxygens it has. But we do know that between 8 and ite, the oxygen decreases by 1, right? If we put a per in front of the chlorate, we add an oxygen, and that would be ClO4. And that's on your sheet beneath it, perchlorate. If we put a hypo in front, it's 1 less than the chlorite, Cl hypochlorite. It would be ClO1. Okay, so if we put a per in front of the sulfate, persulfate, it would be SO5. I haven't confirmed that this even exists, but if it did, it would be this formula, persulfate. And then if we put hypo in front, hyposulfite, that would be SO2. So if you look at these two examples here, the oxygen number is not the same as you look across, like between the chlorate and the sulfate. But in one group, as you go up, the oxygen level increases by 1, right? And that's what you need to notice. So if you know the formula for chlorate, you know the formula for all the others, right? Because you just know it increases by 1 or decreases by 1. So when we're naming these types of acids, like perchlorate, so if we had HClO4 and we want to name it, perchlorate becomes perchloric. So you keep the per in front of it, right? And if we wanted to do hypochlorite, which is HClO, right, it becomes hypochlorous acid because the ite changes to us and the hypo goes along with it. So the only point I'm trying to make is that if you have a per or a hypo, you follow it, like you bring it with it whenever you name the acid. The only thing you translate is the ate or the ite. And also you need to know that within a certain like ion section, right, like the chlorates or the sulfates, that the name ending and the beginning matter and they mean something that you can actually use. And so you may need to reference that. Do you have any questions about that or anything? Okay, so far, just to review, we learned how to name binary. You put hydro in front and you change the ending to ic. When you deal with 3 or more, you use the polyatomic sheet. You change the ending accordingly from ate to ic and ite to us. So that's really important. And then if there's a per or a hypo in front, you keep it even whenever you're changing it to an acid. And also for all acids and bases, but we're dealing with acids today, for all acids, you cross over the charge to figure out how many you need of each. It's not just like a prefix that you do like di or tri. You cross over the charges for it, like an ionic compound. So any questions on that? Okay, so we're going to practice now. I'm going to pass those out. Hold on one second.